One of the most important questions that anyone will ever ask you. Why do bananas change colors? What color do bananas begin as? Of course.
Green.
Did I just have some? Do we just eat all of the green? No, there we go. Okay, very good. So they begin as a kind of green like this, and they become. Did we eat the yellow banana? No, I think I sliced that one up. Okay, so but you know this, right? They begin as green, and they turn to yellow, and then they change color again and become. Is there a yellow color?
Black.
They become green again. Black or brown, I think like a really dark brown color. So banana, a fruit that begins as one color, green, turns a totally different color, kind of different color, yellow, and then becomes a totally different color still, brown/black. Why the heck does this happen? Do you guys actually know the answer right now?
Because then if it didn't happen, we couldn't make banana bread.
The banana, out of the goodness of his heart, said, I want to help human beings, this race of ape, make banana bread. So what can I do for that? Maybe it's not the answer. It's not the answer. It's actually, but you're right. Yeah, we can make banana bread. They're extra sweet when they're like that. Soft, kind of icky, but sweet. Yeah.
When they found out about those new kind of bananas, like every time it mutated, maybe a little bit more happened to it. Like instead of it just being sweeter or changing color, like it could just have changed color more.
So I will tell you that actually could have been the answer, that maybe we could have bred it into them, this color changing, for our own purposes. But it turns out that bananas did that even before humans. In fact, there's kind of this weird way in which bananas, if they had their desires met, they wouldn't even change color anymore now that they don't have seeds anymore. But I'm getting ahead of myself. Let's start with why bananas are green to begin with. Why are bananas green? How would you guess? Why might bananas be green? Steve?
Some sort of pigment.
Well, a pigment means a color, right? So if I'm saying, like, why are bananas the color green? If you say a pigment, that means, oh, they're green because they're made of green things. Which is true. Good, excellent. So it turns out if you put a banana or a different kind of plant, I'm not sure what kind of plant this is, under a really powerful microscope, you'll see that a plant is actually made out of these little rooms, these little boxes that are called cells, like a prison has cells, like a monastery has cells.
So cool.
They're actually called cells because they look like the cells that are like the little square rooms.
Oh, yeah, I know.
The first guy to put one under a microscope said, oh, I know what these things are. Good. And these kind of cells actually look like, rooms, like little squares or rectangles.
They're like cubicles. Yeah.
Yeah, honestly, now if you probably name these things, you probably say, oh, it's a cubicle.
And then
But these cubicles, these cells, have these green little things in them. Actually, if we zoom in, this is actually a different kind of plant, right? But like, you can see it more clearly. These little pigments, all right? These little pigmented micro cells that are floating around in here. And actually, maybe the most beautiful one of all, I think, is this. It looks like a forest. Instead of every one of these cells, it looks like a forest full of leaves. Isn't that cool?
Yeah.
Why green? What are these green things doing? Does anybody know?
Yeah.
They're called chlorophyll or chloroplasts. Each independent one is called a chloroplast. Why do they exist? Steve?
So that they can absorb the sun's energy.
Ooh, so they can absorb the sun's energy. Oh, this is the most beautiful one of all. I was lying before. It turns out that inside of every cell, things get really, really complicated.
The nucleus is in the middle of where's the cytoplasm?
The cytoplasm is the orange stuff that everything is floating in here. We're not even going to talk about any of this right now. There's the sign for cytoplasm up there. We won't talk about any of this right now except for the chloroplasts, which are filled with chlorophyll. What is this?
The sun.
What is the sun?
A star.
True.
It's a whole bunch of.
It's a gas.
Turned into another.
Good. It's made up of this thing called plasma.
It's a gas giant.
I want you to imagine that the sun is a gun.
Okay.
The sun is a gun that shoots out photons.
Okay, photons of light.
Imagine for a second that a photon is a tiny little ball that is like the tiniest piece of light that you can have. It turns out that what photons actually are is kind of like what we're talking about and kind of this totally different thing, and no one really understands how they're both of those things together. But ignore that for a second. Imagine that photons are balls, and the sun is a gun shooting them off. If I took a baseball and threw it at a window, what would happen?
The baseball would bounce off the window.
You're right. It depends on how hard you threw it,
Yeah.
and how thick the window was, right? If I got like the world's like best baseball pitcher to throw a baseball at this window right here, what would happen?
It would
Smash through.
It would smash through this window and go through your neighbor's window.
And what would happen if he threw it against the side of a house?
It would bounce off.
Yeah, right, because that's the side of a house. It's too hard, right?
Yeah.
Now imagine we put the baseball in a gun, heck, in a cannon, and shot it to the side of the house. What would happen?
It would just totally obliterate the house.
Probably like blow through the house, right? Now what if we put it in a gun that shot it at, let's say, 1,000,000 miles an hour?
Okay.
What would happen?
It would probably split light particles and you wouldn't be able to see it.
Something very bad, right?
It would probably go through the wall.
It'd probably go through like a wall, the next wall, like 15 subsequent walls, like in the row of these apartments or whatever, right? Mm-hmm. Now, what if we took the baseball and shrunk it down so it was tiny, so that it was one of the tiniest things in the universe, but then shot it out of a gun that made it that little baseball, that tiny baseball, we'll call it a photon, be literally the fastest thing in the entire universe.
Oh,
This is what light is. Light is a bunch of balls shot out at the speed of light, which is the fastest thing in the universe, all the time. They would be really cool, right? They'd be awesome, right?
Yeah.
They would have tons of energy in them, and they'd actually be kind of dangerous. And it turns out that if you go out in the sun for too long, they actually harm your skin. If you stare at the sun with your eyes for even a couple seconds, it will break your eyes. That is how dangerous these little balls of photons are, because they have so much crazy energy inside of them. I shouldn't say inside of them. They're being hurled at such great energy, right? But what if there was some way, I'm going to come back to your question, that's okay. But what if there was some way of using that energy, of catching those photons? Now, a catcher catches a baseball, and he or she doesn't really do very much with it, right? Like, they absorb that shock. What if they could take that energy and hook it up to a machine? And what if a catcher sat there and caught a ball, caught a ball, caught a ball, caught a ball, and every time they caught it, they had like a lever or something to like move that energy to, I don't know, like power a flashlight, like shoot off more, or I don't know, like recharge a cell phone or something like that. You can actually take that power and use it. I'm going to come back to this, actually. I'm going to come back to this and come back to this. This. Mm-hmm. A chloroplast is like a green catcher's mitt. A chloroplast is the plant's way of having that photon hurtling at your face at the speed of light and then catching it and going like this. Whee! And holding that energy so that other parts of the cell, other parts of the plant can then use that spinning energy. It's not really spinning, but just imagine it like it is, because it's actually kind of awesome. And it kind of gets at what we're talking about. It takes that spinning energy and then can use that energy to do other things. Why are plants green? Exactly as, I think it was you, Steve, who said, to catch the sun's energy. Imagine it like it's catching the sun's light speed balls and spinning around with it so they can do things with that energy. Question. What does a plant want with energy? What do they do with energy? Ted?
What I think they do with it is they turn it into maybe nutrients to help them.
You're saying they turn energy into nutrients?
Yes.
No, they can't do that. It turns out.
That's true.
It turns out that like nutrients are a thing and energy is not a thing.
Right.
By thing here, I mean like something physical, something you could hold in your hands. And energy isn't like that. You can't turn energy into matter, is one way of saying that. What does a plant want to do with energy, Thomas?
It uses it as one of the ingredients for food. Like uses water, sunlight, and maybe some other stuff to make its food.
I love that. You're entirely right. It uses energy to make its food. Do you guys know how a plant makes itself? Where does a plant grow out of? This is maybe the weirdest fact in
The
science.
soil? Right? Soil?
So most people, I always used to think that if you take a seed, you put it in the ground, and you water it, and a giant tree grows up, it's because it's sucking up the dirt and making it into tree. That's maybe, I thought that's why trees are brown, because the dirt is brown. It turns out that that's not true at all. Do you guys know where trees get the atoms that they need to make themselves? Where they get their mass from? Steve?
You get it from the air, water, and sun.
So some of it comes from the air. Sorry, some of it comes from the water, right? But wood isn't mostly water, because if it was mostly water, you couldn't burn it.
Yeah.
It comes up from the core of the earth.
In the big story of it all, the core of the earth kind of is where dirt comes from. If you look back billions of years, but it turns out that dirt and anything from the earth is actually not where most of a tree grows out of. At least not what most of a tree is made out of. It's not made out of dirt. You said also sunlight, but it turns out that sunlight doesn't weigh anything, right? Or let's say that it weighs nothing. It essentially weighs nothing. And like you can't get it doesn't have atoms. Sunlight isn't made out of atoms. So where does it get the atoms from? To grow itself.
Like kind of like in CO2.
You guys are very scientifically literate. What a joy. Plants are made out of air. A plant is really just air squished together. Specifically, it's the part of air called carbon dioxide, CO2, which sometimes is actually a problem what we have right now. We have too much CO2 going into the rest of the air. And can be described as looking like this. And what a plant will do is take the sunlight and use that to catch a CO2 molecule. And it take it and another one that it's caught and take them and squish them together. Actually, try to do that right now. Take one CO2 molecule and another CO2 molecule and squeeze them together until they pop together. And now put those to the side. And I'll take another CO2 molecule and another one, and squeeze them together, put them to the side, take one more, here, squeeze them together, and now take those other two and kind of hold them together in your hands, and go like, and out of those 6 CO2 molecules, do you know what they make? They make a sugar molecule.
Oh.
Sugar is smushed together air. Isn't that weird?
It gets so tightly packed that it kind of turns into a solid.
Isn't that cool? And it turns out that plants build themselves first out of sugar, and they use the sugar to build other things. That's why if you eat grass, it doesn't taste sweet. It's ultimately made out of sugars, but also they take the sugars and build them to other things, and they get more complicated than that. Ted?
Yeah. So is it like I play soccer and sometimes I run and then
I thought you were saying, and sometimes I get bored and eat the grass and I miss a ball as it goes past me. Which is, we were talking about the soccer
I get really tired and like when I run I'm like sucking in a lot of air and so then when I drink my water it tastes sweet. Does that have something related to the air?
I don't know why that would be, except maybe that your body really wants sugar, really wants water, and so when it finally gets to, it's like, hey, like your brain's like, I want to convince this guy to drink more of this right now. You need this, like. So your brain essentially one part of your brain tells the other part of your brain like, imagine that this is sweet, imagine this is sweet. But I don't know. I'm totally making that up. I actually have no idea. You take these and you make them into this. And there's a couple other things that go on too to make this. And if you guys ever study chemistry, you will be studying organic chemistry specifically, be studying about how processes like this work. So plants grow out of the air. So why are bananas green? We almost lost track of what we were talking about for a second, all right? Why are bananas green? Ted.
Is it the atoms? or more like the nutrients that they from the the gathering of the sunlight that.
Good. They're green because of the chloroplasts or chlorophyll,
Yes, that's
which are designed to allow them to grab air to make themselves.
right.
Excellent. Okay, weird question. Why are bananas yellow? This is like the best part. Oh, hold on for a second.
Okay.
You can raise your hand if you like.
Yeah.
Tell us.
They kind of just they kind of when the seeds are come out they kind of change the traits a little bit from in their DNA.
So it turns out the DNA actually stays the same, but the DNA gives instructions to change the color of it.
Yeah.
You might that has something to do with their seeds, Steve? Why are they yellow?
So they turn yellow because some of the chlorophyll just breaks down.
Good. The plants decide to kill the chlorophyll, to get rid of it. And it turns out that they are secretly yellow all along. Interesting question. What color is this leaf?
Green?
Wrong. This
Yellow.
leaf is secretly red. Secretly, this leaf is red right now. It's just that there's so much chlorophyll in here that you can't see the red. And when, this is a maple leaf, and when it kills off the chlorophyll, you can see the red through it.
Oh, so the chlorophyll is inside of those little cubicles, and then the actual red is behind it.
Yes, insofar as I understand this. I'm actually kind of confused as to why you can't also see the red through here. This is a mystery that I'm trying to get to the bottom of right now. This,
Like,
of course,
even if you cut it, it's still, the inside isn't red.
I know. Yeah, and so yeah. Let me be open about that. Like, I don't understand what it means that it's secretly red inside. I was talking to some friends who are scientists, and they said, "Nope, that's what it is." And I forgot to ask them that question when I was talking to them. So maybe we can actually let me try to rustle up an answer for you about why, like, how they're secretly red. Can I get back to you about that?
Sure.
I will do that. You can see the color change right here, and this is my favorite one. Look at this. Isn't that cool?
It's just beginning to lose all of its chlorophyll.
And you can see all three of the colors on here. I love it so much.
Oh, so then below the red, there's yellow?
In this one, it seems to be that. And I actually don't understand why some are red and some are yellow, except I kind of do. Why are leaves secretly red, yellow, or orange in the first place? Why aren't they just green all over? What is the red part of it? If the green part of it is the chlorophyll, what's the red part of it?
It's the
Or
stuff
the
behind the chlorophyll?
And what is the purpose of the yellow stuff or the red stuff? I should say, let's bring it back to bananas. Bananas that are, here's a plant saying, that are yellow. What is the yellow stuff doing in there? Do you guys want to know?
Yeah.
Okay, so imagine, is it okay if I just cut into this? So imagine that this is a chlorophyll that's grabbed a piece of sunlight, grabbed a photon, and spinning around, spinning around, spinning around. Everybody do that. Spin around, spin around, spin around, spin around, spin around, spin around. Whoops! And it drops it. And one of the photons goes shooting off through the banana. Now remember, those things are going the speed of light. They're very, very dangerous. What's it going to do when it hits one of the next cubicles?
It's gonna kill it.
Smash through it. And it turns out they can cause terrible damage to the cells around there. They can even damage the DNA in the very center of those cubicles, in the center of those cells. And that can actually kill or cause great damage to a plant or an animal. Actually, we have the same kind of problems. And so the plant has developed pillows. We call that kind of dropping of the photon or the dropping of the energy, and they're going whoops, and it's smashing. There's a word for that. It's called oxidation. Kind of a dumb word, honestly, if you look at the history of it, because it has nothing special to do with oxygen. We call it oxidation, and we call these pillows antioxidants because they catch the oxidants. They catch something called free radicals, and they absorb the blow of it. If it wasn't for these yellow, or in some plants, red pillows on the inside, the plant will be killed by the sunlight. The sunlight is too dangerous.
Well, sometimes they just wilt in the sunlight. Is that because they get too much of it?
I don't know why they wilt like that. That's a water. Sometimes it's a water thing, and sometimes
It's just too much sun.
I don't know. They have antioxidants. I'm not sure. It turns out that actually eating those antioxidants is helpful for people too, because then our bodies use those antioxidants to make sure that we don't when our cells drop the energy, the different types of energy, it doesn't destroy our cells. We actually use these ourselves. We put these pillows inside of ourselves. We've talked about why a banana is yellow. We've talked about why a banana is green. Oh, why does a banana turn from green to yellow? This is actually kind of awesome.
Like,
Thomas? Because we talked about that, like, it's secretly yellow all along, so why does it kill off the green? Why do bananas kill off the green and turn yellow?
Because of the kind of the pillows kind of things.
Well, the pillows are still there even after it's green, right? So why does the banana kill off the green catcher's mitts? Why does it kill off the chlorophyll? Steve?
Is it because when it's gotten riper, then it just has no need for the chlorophyll to be there?
No. That's actually a good thought, and I had that one myself. But it turns out that if the plant had its way, it would always be green. It would always keep getting more energy. It's kind of a weird waste for the plant to get rid of the energy producing part of it, right? Because it can always grow more bananas for next year or for the next crop or whatever.
So I think it might be because it keeps on dropping all of those protons. Like when it's got the energy, right, it's storing it. Then when it lets go, it breaks one of the cells, right?
Oh, so maybe that the reason it kills the chlorophyll is by accident.
Yeah.
That's actually a really good guess. It turns out that the plant has a very good reason as to why it wants to turn yellow. Question. Mother mammals usually keep their babies very close to them, right?
Right.
Mother plants. Do they want to keep their babies close to them?
No.
Why not?
They want to get them as far away as they can so they
Why?
can spread their seeds.
And why is that important?
So then they can populate the forest.
There is some aspect of that. It turns out that if a plant would just drop its seeds immediately underneath it, then it would be in the shade of the mother tree,
Right,
and the mother tree
yeah.
would essentially choke it off, right? So a good mother mammal typically wants to keep its babies very close. A good mother plant wants to get its babies as far away as possible.
Yeah.
What's this?
Oh, those are the maple seeds.
Those little spinners, those little helicopters from maple seeds. The idea there is that instead of just plunking the seeds down, they can spend a few seconds in the air, and if it's windy, they'll kind of blow a little bit away. Not super far away, but a little bit away. What's this?
Dandelions.
What's the idea with that?
They blow really far away.
Super far, right?
Coconuts.
What's the idea with the coconut?
They go super far because they float down the street.
They first, like, they'll roll away if it's on a hill, and second of all, like, if it goes into a stream, it could go actually into the it could go off into a stream, a lake, the ocean, go to a different island, and actually start planting there. Coconuts are maybe
cool.
the best at this, but the most brilliant of all
Is the banana.
is the banana, or at least I should say all kinds of fruit. How does a good mother fruit tree or fruit plant get its babies to go far away from it?
Gets the animals to do it. It eats its
pays
fruit.
an animal to take it away. In the same way
It
that
makes it sweet, and then the animals eat it, and then they run off.
you're exactly right. In the
And
same
then
way
they
that
pop out in the feces.
you guys really know your animal poop stories really well. No, this is good. This is fantastic. No, you guys are exactly right. In the same way that you might pay a taxi cab driver to take you far away, you give him or her what he or she wants, money, and they'll give you what you want. The plant says, hey, wait a second. What if I can give my seeds to an animal, a big animal, who will take them, move them around, and then give them a nice little plot of land to grow in. And they thought the plants obviously can't think, but the plants essentially decided, take a flower, take the part of the flower that the seed grows in, which is this middle part right here. That middle part right there, it's called the ovary.
Ah, you killed it.
It was already ripped from its roots and was not long for this world. I don't feel terrible about that. Take the seed, and this one does not have any seeds. This flower has not gone to seed. But the seed would grow right in the middle of there. And the fruit plants say, I'm going to take this and pump it up with sugar. Give animals what they want, because everybody likes sugar, right? Give animals what they want. Isn't that awesome?
Yeah.
And it does that specifically so a big animal, usually a mammal, it's not as cool a video, will come by and eat it. Swallow the seeds, which are hard so it doesn't just chew up the seeds, and then poop them, walk a long way away and then poop them out. Poop is actually pretty good dirt for a plant to grow in, so it even just provides a little garden to grow in.
Don't make it grow themselves though.
You're right, because that actually would be bad, because there wouldn't be sunlight inside of them, right?
Yeah.
All right. So why is a banana green in the first place? To catch the photons and keep them spinning to grow itself out of the air. Why is it yellow? It's yellow because of those antioxidants, the parts that are pillows that absorb the impact of the dropped photons, the dropped energy. Why does it turn from green to yellow? To tell animals, it's time to eat me! I'm sweet now! Have you guys ever tried to eat a really green banana?
It tastes horrible.
Yeah, they're not sweet. They become specifically sweet at that one time because the seeds are ready. So the banana turns yellow to tell the animals that its seeds are ready. Wait, what's the problem with that?
We eat them and then it goes down the toilet.
Do bananas have seeds?
Oh no.
No.
Don't tell the bananas that. They're still doing this whole thing of turning yellow and turning sweet for us because their seeds are ready. They don't know their seeds are ready. They don't know that they're mutants. And if they found out about that, they probably would actually stop turning yellow, at least in their own sort of desires for that, because there wouldn't be a purpose for turning yellow anymore. Final question, why do bananas turn brown or brownish black?
Because they get run?
Hold on, yeah?
Because maybe more antioxidants get to it?
So there is some element that it really just is like the plant is approaching death, and that is why leaves turn brown and die in the winter. The tree just stops saying, let's support these, and so instead the tree's like, let's just let these die out here. There's a whole reason why some trees do that. But no, there's actually, it turns out, maybe another reason why they turn brown. The plant chooses to let to turn itself brown, and it turns itself kind of rotten. Do you guys know why?
Because he wants to drop it so other animals eat it.
Good. Actually, you're kind of onto it. Have you guys ever been to a rainforest before? A jungle before?
No, but we've been to Singapore.
It's difficult to see what is 10 feet in front of your face because there's so many plants everywhere. The bananas turn yellow from green in order to tell other animals, hey, I'm ready! But what if animals can't see them? Then the only way of telling the other animals that they're there is to start stinking. Is to communicate through smell. And so bananas turn brown and start stinking in order to communicate with animals that are farther away. Particularly, some people think, this is a bit debated, some people think monkeys specifically, to communicate to monkeys that, hey, we're here, come devour us. And it turns out that lots of animals, not us, but lots of other animals, love brown bananas. We like them when they're banana bread, of course. But it turns out lots of animals love it for that reason, just having them raw, too. Okay, so bananas. Why are they green to begin with? Hands.
So then the animals don't see them.
That is actually, I suppose, an answer. I'd never actually thought about that. Yeah, I wasn't thinking of the sort of the coevolution sort of aspect of this, but yes. Why else are bananas green to begin with?
To absorb sunlight.
Good. To catch that sunlight and keep it spinning. Why are bananas secretly yellow to begin with? Ted.
I think it's because
Think of the pillows.
right. Because it starts to get riper. No.
That's why we get to see them as turning to yellow, but why are they secretly yellow even at the beginning?
So then so then the chlorophyll cells don't get damaged.
Good. It's so when the chlorophyll accidentally drops not protons.
Photons.
Photons, thank you very much. When it drops one of the photons, when it drops some of that energy doesn't just go smashing through the cells, through the cubicles, and destroy everything that we love and hold dear. They're yellow pillows. Carrots are orange because they have orange pillows. That's any comparison there. And why do they turn from green to yellow? Why do they kill off the chlorophyll?
So they can get ready to be eaten.
Yes, and they can tell animals, hey, I'm ready to be devoured alive now. And why do they want to do that?
Because
So then they can spread their seeds, which of course they're too dumb to know that they don't have any.
Whoops. Yes, excellent. And why do they turn brown before they actually die?
so then they can stink, and if any animals don't see them, they'll smell them.
Yes.
Yes. Wait, isn't that to just give the bananas to have an extra chance to be eaten?
Yes. Yes. In order to attract potential eaters and
Right.
seed carriers. Excellent. And now we know why bananas change colors. Thank you very much.